All right, this is the third video where we're talking about the alternating series, and we talked about if it converges, and then we talked about the sum and the partial sum and the remainder, and now we're going to talk about absolute or conditional convergence. This is an introduction. This is your big picture, and that would be optional. It's 30 minutes, but if you like to see this Stillwater guy, like really explain the big picture, then I recommend watching this. This explains the process and actually only has 2 examples, but they would be helpful if you want to, that will adjust, okay. If you want to kind of zoom ahead and skim over the examples, it's not very hard. So what is fun about this absolute or conditional convergence is that some alternating series, you guys, are not alternating. Like they'll have 2 negatives, 2 positives, and then there might be 3 negatives and 5 positives, all right? And the following test can show whether the original series converges or diverges. So this is for, like, it's not exactly positive, negative, positive, negative, positive, negative. And on the video is a really good example of it just being totally random if it's positive or negative. So what the absolute convergence theorem is it says if the series with the absolute value converges, then the original series converges. So by taking the absolute value, we're really making the whole thing positive. So we're pretending it's not alternating at all. Once we pretend it's not alternating, we can see if it converges. Now, if it diverges, then we have to try something else. So remember when this used to be just -1 to the nth power? Well, now look at this crazy thing. -1 to the nth times n plus 1 divided by 2. That's where you're going to get your crazy pluses or minuses. Oh, we're going to try some. Okay, let's just get an idea of what this looks like. Ready? So when n equals 1, that's where we start. N equals 1. Well, the denominator is 3, right? That's nice. Yeah, there you go. So if this were 1, then this would be 1 plus 1, which is 2. 2 divided by 2 is 1. So this whole numerator is 1, which means this is negative to start. Now let's make n equals 2. And in our denominator, we would get 3 squared, which is 2. Okay, watch. 2 plus 1 is 3 times 2 is 6, divided by 2 is 3. So do you agree this is an odd number? So this will be negative again. So we have a negative and then a negative. Now let's do n equals 3. 3 cubed in the denominator is 27. 3. Okay, 3 plus 1 is 4. 4 divided by 2 is 2. 2 times 3 is even, right? So if it's even, now what do we have? We have a positive. Okay, n equals 4. N equals 4 would also be a positive. So there you can see that we have negative, negative, positive, positive. Fun, right? All right. So what we're going to do is we're going to rewrite by removing alternating term. So just take out that whole part that switches. So to rewrite this, it would be n equals 1 to infinity, and it would be 1 over 3 to the n. Wow, that's cute. Isn't that cute? Okay, is this a p series or a geometric? Think about that. P or geometric? P or geometric? Maybe I can rewrite it to help you jog your memory. This can be rewritten as 1/3 to the n. Okay, now tell me, P series or geometric? This is a geometric. And does this geometric converge or diverge? This geometric series converges because why? Because, or since, oh my goodness, I was going to write C-A-U-S-E, because R equals 1/3, right? Okay, so if the absolute value of the series converges, then what do you say about this? Then the series converges. So we say this original series, here's our conclusion, our answer to this example 1. The original series, -1, n to the n plus 1, all over 2, that's a 2, 3 to the n, and we say this converges by, or we say it converges, cross that off? Absolutely. Are you sure? Absolutely. Converges absolutely. Okay, here's the thing though. The converse of the absolute convergence theorem is not true. Hold on. All right, so this is interesting, okay? If something converges absolutely, then you can say the original function converges. But sometimes the absolute doesn't converge, so the absolute diverges. Then what we say is that this converges conditionally, okay? So there's a condition on it. All right, let's turn the page. So in order to do these, we're going to check for absolute convergence first. So write that down without the alternating series. And we have here, but this is a key step, you guys. Check for the absolute convergence first. Oh, I think I switched my blue pens. I'm going to rewrite this as 1 over n to the 2/3. Now you tell me, does that converge or diverge? What kind of series is it? Do you agree this is a p series? Now when p is a fraction, when r is a fraction, it's good, but when p is a fraction, it's bad. So it's a p series with p equal to 2/3. So this actually diverges. What? So the absolute value diverges. So the absolute convergence diverges. So what we're going to do is we're going to see, well, wait a minute, does it converge conditionally? Okay, does it converge conditionally? How do we do that? Conditionally. Well, we're going to use the alternating series test. So again, this is a little review of the alternating, we're still in the same unit, alternating series test. Okay, so how did that go? There's two things, right? Number one, does the limit of a sub n converge? The limit, sorry, does the limit go to 0 is what I meant. Okay, as n goes to infinity, does that limit approach 0? What would you say? I would say yes, check. And the second thing is the next term less than or equal to the previous term? N plus 1, I need a little square in there. Is that less than or equal to this? Now, if the denominator is bigger, then the entire fraction is smaller. So this is yes. Okay, do you see here how the absolute value did not converge? It diverged, but it did converge just using the alternating series test. So what we say is that this converges conditionally. It has a condition on it. What's conditionally mean? You may go to prom, but you must be home by 12:30. That's a condition your parents set on you. So this converges conditionally. It only converges when there's no absolute value. And that's by the alternating series test. Check. Next example. Okay, last one. So what do we check for first? We check the absolute value. So if we do, a little absolute value around this, what do we get? We get, just make it positive. So we get this, 1/2 times n plus 1. Now, this looks like a geometric series, but it's not quite a geometric series. So do you remember which test do we use when something looks really close to another one, but not exactly? Do you remember that? We're going to use direct comparison. Direct comparison test. And we're going to compare it with 1/2 to the nth power, which is geometric. So which one's bigger? Let's see. 1/2 to the n plus 1. Now remember, this power is growing, but it's only growing the denominator. So since this power is because 1 doesn't grow, then this is less than this. And based on the geometric series, if r is 1/2, does this converge or diverge? If we have r equals 1/2, then this converges. Now, do you remember what happens? I draw my little graph, okay? If the one you picked, the bigger one, converges to a number, not infinity, it goes to a limit, then if one's less than that, then what has to happen? This has to hit that limit. It can't cross it because it has to be less than the b the entire time. So if the bigger one converges, then we know this also converges. Now, did we do that absolutely or just the conditional? That was the absolute. Awesome. So we say that this series converges absolutely. Are you sure? Absolutely. Is there an e there? Let me see. I don't know. Yes, okay, there is. Converges absolutely because, well, because why? The absolute value of this series converges, and which test did we use? The direct comparison test. So that's nice. We did a review of the p-series, the geometric series, and the direct comparison. Now, my spelling, does comparison have one R or two S's or one S's? I forget because I'm not that good of a speller. All right, here's what I recommend. Do you have space down here? I would recommend doing the 2 examples from the video. They're interesting. He takes a long time to explain them, where I go very fast. So I would go to YouTube right now. Oh, you're on YouTube. Oh my gosh, this is a video in a video. It's a meta YouTube instructional video. So go here, and he re-explains the whole test. And then there's 2 little examples if you want to add those to your notes. But then you're going to go and do just a little bit. Do these converge absolutely or conditionally, 41 through 49 odd? Don't forget about calcchat.com. calcchat.com. It works through all the problems for you. Thank you.